The session's agenda is about ADF introduction. So before step into that ADF, so first of all, you know the full form of this ADF, Azure Data Factory. Okay, is one of the cloud ETL. But before step into that ADF, first for data engineering, especially in Azure cloud platform, we have different products about Azure Data Engine. So what are those products we are going to understand first? First, the fundamental product here in Azure Data Engineering, Azure SQL. And next important product, Azure Data Lake. That means this is one of the storage account. Different types of storages are there into the Azure. So what are the different types of storage? What is the purpose of each one? Step by step. Once we step into the technical activities, we will be understanding. And one more thing, Azure Synapse. Then our Azure ADF will come into the picture. The ADF itself, Azure Data Factory. Let me write it its full form, Azure Data Factory. But ADF itself cannot solve all the kind of problems about the data engineering activities. Additionally, how to use Azure Databricks. Okay. And also to capture the streams, you have one more product here, Azure Stream. Nowadays, generally databases are RDBMS databases. But RDBMS databases cannot solve all kind of problems. For that, the next level databases are NoSQL databases. But in the NoSQL databases, there are different categories. Among them, Azure is also having one more database. That is one of the NoSQL database comes under document storage category. That is Azure Cosmos DB. So still other products are there, but these are major important products about the Azure Data Engineering. Once we understand the purpose of each and every product, then we are going to discuss about data engineer responsibilities. Okay. First, let me explain about these products first. Among all these products, then you can understand what is the importance of ADF. I'm going to talk about Azure SQL. This Azure SQL is cloud RDBMS database. That is used only for OLTP. Mr. Shankar, what is the full form of OLTP? Online transaction processing. Then generally the systems which are going to capture end user transactions. Okay, whether suppose take an example of any banking or any other application. User is to interact with the application. User performs the transactions. These transactions will be captured and recorded into OLTP databases. In the place of OLTP databases, most of OLTP databases are in RDBMS category, Relational Database Management System. But here there is a word called Cloud RDBMS. Relational Database Management System, okay. Then we are saying that a Cloud RDBMS. Within the cloud. That means within the cloud means generally if it is if I want to set up on database server means what is the process? First, I need to purchase server and install infrastructure for that. That means the physical machines. On into that physical machines, operating system installation. On top of operating system, application server and database installations. Then I need to run it. But if organizations are bigger, That means if load is very high, generally one single system, that means one single node databases are not worthy. That's why they are using distributed systems. That means more than one CPU. More than one CPU is acting as a database server. That means a cluster is acting as a database server. For example, you take a Oracle database. In our case, for small organizations, Oracle server means that is one CPU. But for the biggest organizations, definitely the load is high. They have to go for distributed system. That means a cluster is going to act as a server. But a cluster is going to act as a server means, first of all, organization has to establish one data center. In the data center, suppose with the 10 systems, you want to set up a database server. First, they have to purchase physical machines, somewhat high-end physical machines. Then the next level, the request goes to operating system team. Once their work completed, then it will go to networking team, because all these 10 systems to be in a network. Then security team. Got it. In this way, so much of process will be there. Not only establishment of a data center infrastructure, on top of that infrastructure, a lot of admin stuff is there. But in the case of a cloud or DBMS or any cloud servers, you need not to worry about. You need not to worry about infrastructure and additional stuff. Of course, administrative stuff will be there, but very little. Suppose previously some 100 administrators are working for your organization. Now 1 or 2% is enough for that. On that way, by having inbuilt security, inbuilt networking, inbuilt infrastructure, everything will be provided to you. Just by doing single click, you can set up, you can configure your database, and you can deploy your database. So, but this Azure SQL simply is a cloud RDBMS database, but used only for the OLT. That is not fit for the analytics process. Because in the case of analytics, most of processes are batch processes. The batch processes are going to work with more volume of data. That's why OLTP systems are not good for analytics, because basically they are having less capacity. Got it? So this is the first important product, especially in Azure data engineering, that is Azure SQL. So normal OLTP databases are there. The OLTP RDBMS, that means DBs. Most of the DBs are in RDBMS. For this example, the popular market product, popular products for this, you have Oracle, MySQL, that is which is Apache product, DB2. Even if it is Microsoft, you have SQL. This is Microsoft SQL service on-premise. All these are on-premise databases. Got it. But here we are going with cloud, Azure SQL. Suppose let's talk about only Microsoft. Sir. If I go with SQL Server or if I go with Azure SQL, what is the difference? What are the advantages that I'm getting if I go with Azure SQL? Suppose I want to set up this SQL server for my organization. What is my process? First, physical hardware, OS, network, a lot of remaining things I need to take care of. After completion of all these things, I need to purchase license of SQL server from Microsoft. Got it. So here, if I go with Azure SQL, no infrastructure for. Okay, no software license, no need to purchase software license. Okay, of course, security that I have to maintain, but most of our security is pre-configured. So previously I need some 10 people only for security, now only one person is enough for. Okay, so such kind of benefits that I am getting with Azure SQL if I want to use OLTP system. But there is a problem with OLTP systems. Basically, these OLTP systems are having less capacity. But your organization is bigger, daily transactions are more, that your organization has some 30 years history. Your entire 30 years data cannot be kept into your OLTP systems. Got it? That's why organizations will be compromising. They maintain only recent data into that one. Only recent data. Why? Because they are having less capacity. Suppose one organization is producing monthly 1 terabyte data set. If you count it for a year, 12 terabyte. That means that organization is running for the past 10 years, 12 terabyte into 10, 120 terabyte of data will be there. If 120 terabyte of data is into OLTP system, the process will be slowed down. That's why entire organization history they don't keep into OLTP. For that, they need storage, data warehouse storage. So here for the data warehouse, we have different products. One is Azure Synapse. Azure Synapse Analytics is a service, but for that database is Azure Synapse DB. The Synapse DB is data warehouse environment. Of course, RDBMS, okay, is data warehouse in Azure platform. But problem with this warehouse, problem with this Azure Synapse is that is only structured data. That can handle only structured data. But the data are into different varieties. What are the basic varieties of the data? Structured, unstructured, semi-structured in this way. Generally, if you talk about any database, the databases can handle almost all structured and little bit of semi-structured. But for the biggest enterprises, only 20% of data will be into structure, but remaining 80% is unstructured only. What are the examples of different structured or unstructured? Sorry, examples of unstructured data especially. PDF. First of all, what is the meaning of a structured? What is the meaning of a structure? For example, I am giving you one thing. Suppose, as I said, is the table data 101 Ravi and 102 Giri 102. Is it structured? That is, its first point number one, it is not structured because the record patterns are different. The schema of each record is different. Schema means structure. Suppose what is the schema for the first row? ID, some name. But second row, that is different. Name and ID. Record to record schema is different. That's why it is not structured. For example, if the data is like this, now you can say it as a structure because whatever the pattern you have for the first row, same pattern for second, third, and all the remaining rows. Generally, RDBMS can handle such kind of structured data only. The examples for structured data, CSV files, Excel, even RDBMS table data, all these things comes under a structured. But if you talk about one organization, especially if you talk about customer reviews, these customer reviews are not structured. For example, you are commenting about some product, LG TV, clarity is good. This is the review by one of the customer for the LG. What is the shape of this? Suppose second customer wants to comment about same TV of LG, but his comment style is different. Record to record, the pattern is different. That means the schema, the pattern is different. So such kind of data is called unstructured. So in the case of Synapse, if my data is structured as a warehouse, I can deploy my structured data into Synapse. But if my data is unstructured, then I have one more product here, Azure Data Lake. So again, in the Azure Data Lake, different type of your data objects will be there. So once we step into technicals, we'll be discussing and then we'll see practically about it. So if it is Azure Data Lake, the basic advantage is it is offering you unlimited data storage. Nowadays, organizations are worrying about the big volumes of data. See, 10 years back into the industry, 10 years back, 1 terabyte means that was big data on that moment. But nowadays, 1 terabyte is very simple. Okay, even single table is going to contain 1 terabyte of data nowadays. But for most of organization, the data reached per day hundreds of terabytes. Suppose you know data volumes. What are the basic data volumes? You are saying something as MB, GB. You know, 1024 MB is 1 GB. 1024 GB is terabyte. 1024 terabyte. Peta. Same thing, multiples of 1024, next level, exabyte, zettabyte, like this. Most of organizations have already achieved zettabytes also. Understand? So all of you might have heard about Hadoop kind of systems. In 2011, Hadoop has achieved unlimited storage feature, that to multi-petabytes of data. In the case of Hadoop kind of softwares, Hadoop kind of frameworks, the backend storage is HDFS, Hadoop Distributed File System. By taking essence of HDFS, nowadays the cloud organizations are building a data lakes. That means indirectly for the data lakes, the backend is HDFS kind of storages, distributed file systems. So in the case of distributed file systems like Hadoop or in the data lakes, there is a technique, there is a benefit for us, that is unlimited data storage. Whether our organization have achieved petabyte scale or zettabyte or whatever it may be, it doesn't matter. So you need not to worry about tomorrow's data volume. What are the volume maybe that can be stored into data lakes. The second benefit about the data lake is it can store any variety of the data. Already I told you. In the case of RDBMS, only you are going to store and work with structured and little features of semi-structured also. But here, any variety of data that you can store, that can be text data. Your customer reviews are examples of text data. And even you can store images, audios, videos. But in the case of RDBMS also, to store these things, you have chance. You have blob objects. By using blob objects, you can store this unstructured also. But they can only store, but they cannot process them. They can only store, but they cannot process. Got it? But here, you can store, you can process, and you can do anything. That's why in the place of data warehouse, especially for big volumes, you are using two things. You are using two products. I'm sorry. One is Azure Synapse. Second one is Data Lake. But in the Data Lake, you have different flavors. Gen 1, Gen 2, like that. You can compare them with the versions. Okay. So what are the key features of Gen 1? What it cannot do? Why next version called Gen 2 came into the picture? Those discussions, once we step into the technicals, we will see. So till now, we have discussed about three products. One is Azure SQL, Data Lake, as Synapse. Now you can understand the importance of ADF. So for them, let me take one picture. One minute. Yes, open. Sir, I told you something about OLTP. What will be there into the OLTP? OLTP databases. End user transactions will be stored into the OLTP. But you take any organization, the OLTP server is not single. They are using multiples of OLTP systems. That to different databases. Database server 1, server 2, server 3 like this. Maybe some database servers are on-premise database. Just for example, the first database server is Oracle. Next one DB2. For next one is SQL server. Next one might be Azure SQL. Let it be. Azure SQL is cloud OLTP. Remaining the first three on-premise OLTP. So I have a question here. Why organizations are using multiple database servers? Question number one. Why they are using multiple database servers? Suppose I am running a small organization. I have 2 or 3 applications, that's it. But think in big organization point of view, hundreds of applications will be there. If all applications are reading data from one single database and writing into one single database and performing updations into one single database, then the database server performance will be down. Understood? That's why for different applications, different databases they will be used. That too, why not single database? For all database servers, why they can't use only Oracle? That depends on the applications. Maybe some applications are compatible with SQL server. Some applications are very much compatible with Oracle. That's why for different applications, different databases they will be used. But already I told you the problem with OLTP system. What is the problem with OLTP? Less capacity. That's why recent data will be maintained. Maybe 2 years data or 3 years data like that. But your organization has 30 years industry, where that entire 30 years industry will be there. That is into your warehouse. Especially in the case of Azure, for this warehouse, you have 2 products. One is Lake, second one is Synapse. Okay. So here, let me write them. The first one, let it be as Data Lake. The next one, Azure Synapse. Okay, today suppose 1 terabyte transactions have been done. Today 1 terabyte data produced means by tomorrow that will become history. Got it? On daily basis or hourly basis, this data has to be dragged into these warehouses. Maybe some data into Synapse, some data into Data Lake. Like this. But how to bring this data? How to bring this data into from OLTP systems to the data warehouse? For that, different data migration tools are there. These things are called ETL tools. What is the meaning of ETL? Full form: extract, transform, and then loading. Okay, the popular ETL tools like Informatica. Still other tools, can you name something? No, Teradata is a data warehouse environment similar to the Synapse. Informatica, Data Stage, Pentaho, Talent. In the case of big data, the industry who are using Hadoop kind of systems for the warehouse, they are using Scoop. In this way, different. Similar to those ETL tools, here you have one cloud ETL, that is ADF, Azure Data Factory. Understood? So by using ADF here, especially in Azure, what you can do, you can connect with any kind of source data, and you can perform transformations, and then you can load into your target systems. So these operations that you can do. Got it. So once data is kept into this Synapse or data lake, and further next process, next analytics process will be done in the next level by using Databricks, and after that the visualizations will be produced by Power BI or Tableau kind of systems. Got it. So this is what exactly the importance of ADF. In ADF, let me write something about ADF. Already you know the full form. Please do some comment on this. In general, that's it. Simply is a cloud ETL. But Microsoft is saying the definition for the ADF is a orchestration tool. Okay. So what is the meaning of here data pipeline orchestration? Okay. In coming concepts you will be understanding. So till then have an idea, like other tools, like Informatica, Data Stage, Pentaho, Talent, or Scoop. Here we have a cloud ETL, that is ADF. Okay. Actually, in the case of ADF, we have two types of process: ETL process and also ELT process. ETL means extract, transform, load. ELT means reverse: extract, load, and then transform. But I have a question: when to use what kind of process? When to use what kind of process? When to use ETL? When to use ELT? First, forget about it. First, tell me the importance of transformation. Example of transformation. Transformation means converting one format to another format. Why you should transform? Converting from one format to another format or one shape to other shape, that is okay. Why you should transform? Because you are extracting data from OLTP system. OLTP system is RDBMS. RDBMS data is already structured. Understand? For example, let's talk about OLTP database. There are columns. Student ID. I'm talking about students. Student date of birth. And the course he has joined. Got it. Suppose the first, this is the structured data. The data is like this. Tell me the date. Okay, not today's date. Let me go for a month, sorry, day and month and year. And course, let's say Java. In this way, second record, third record, fourth record, thousands of students that you have. Okay. So whenever a student has joined or whenever a customer has joined, he is submitting his data at the time of sign up. But end of the day, you require something. Age group and number of students. The age group, the report what I need is less than 30 years. Let's say 300 people. 30 to 40, 500 people. That kind of report I need. So your management is interested about which group based on age group, the count or some other analytics they want to apply. But there is no column in the source data. There is no column called age group. There is a column called what? Only data part. Got it. Now I want to extract this data. That is called extract. After that, I have to transform my data of birth as age group. That is what a transform. And then I will load into my target system, maybe Synapse or maybe Data Lake. Understand the point? So If it is ETL, if data volume is small, you can perform like ETL. But the change, a small change in that scenario, my below data is not 1 terabyte data, below data is 50 terabyte of data. Below data is 50 terabyte. At the time of extracting data only, if you perform transformations, the process will take days time, not hours time, days time. Maybe 3 days, maybe 4 days it will take. That's why for big volumes of data, ETL process is not recommended. For that, what is recommended is ELT. First extract, don't perform any transformation, as easily load into your target. Once data loaded into your data lake or your synapse, then perform the transformations. If I perform transformations at data lake level or synapse level, the process will be faster. Got my point? That's why extract, load, and load. Sorry, extract, transform, and load. That is previous process. Now reverse it. Extract, load, and then transform. So this is what. So based on this information, you can say ADF as is mainly used for ELT. ELT in a cloud. Understood? So this is what you are going to learn mainly as part of this course. But still you have other products. Basically your role is with ADF, but you will have to interact with other products. Got it? For example, your client is using Oracle as OLTP and Azure SQL as OLTP. First of all, you should know how to connect with them. And you should know like how to create tables and how to maintain schemas into Synapse. Then only using ADF, you can extract data from Azure SQL and you can load into Synapse and also into data. But at the time of loading, you need to create a lot of connections. Got it? Even though you are an ADF developer, you will be interacting with other data engineering products. Got it? So, and one more thing, there is another important product which is Azure Databricks. Azure Databricks is a Spark environment in Azure Cloud. Okay. See the Databricks. So let's not talk about Azure Databricks. First, let's talk about only data. Databricks is a Spark environment in Azure Cloud. What is the use of a Spark? Spark is high-speed processing system in a massive parallel way. Okay. Even terabytes of data also will be processed within minutes. Multi-terabyte data also will be processed within minutes. Got it? Suppose, come back to your Synapse. Basically, your Synapse is faster. But up to how much volume it is faster? Maybe less than a terabyte data or less than 2 terabyte data, the Synapse process is fast. Got it? But if data volume is 10 terabyte, 20 terabyte, still if you run your processes with your SQL Synapse by using the service called Synapse Analytics, again it may take days time. Suppose if a process runs for 10 hours, the billing will be applied for 10 hours in the cloud, right? Got it? One is time waste, second one is budget waste. In that special moments, if they feel something is going slow, some process is going slow, then only your organizations will be using Azure Databricks. Same Databricks in Azure Cloud, that is called Azure Databricks. Understood? But Databricks is not only for Azure, sir. Databricks are available for AWS. That is called AWS Databricks. Same Databricks available for Google also. Google Databricks. Okay, so nothing. Basically, now we know the importance of Databricks. You know the importance of Databricks, but especially in Azure, this Databricks should interact with the Azure data engineering products, right? So same Databricks compatible with Azure data engineering products, that is Azure Databricks. Got it? By the help of this Azure Databricks, you can process any amount of data with a high speed. Now I am telling you some process. Importance of ADF and Databricks combination. Can you tell me one scenario for this use case? We can store the ADF purpose, extract, load, and then transform. Extract, load, transform. If ADF existed, then why, especially for some processes that I have to use Databricks. Come back to same previous scenario. The story is you have 50 terabytes, small volume or big volume? Big volume. If I go with the ETL kind of style, extract, transform, and then load into my Synapse, the process will be days. The process will be days. Instead of doing that, first extract, load into Synapse. Once loaded into Synapse or Data Lake, run the job with the Databricks. Then even though 50 terabyte of data is there, the process is faster. Maybe suppose the previous process is taking some 10 hours time means, now Databricks will take maybe 20 minutes time. Hours will become minutes. Days time will become hours. That much speeder it is. Spark has a recorded proof by organizations. Spark has achieved 1 terabyte of data. 1 terabyte of data sorting in 1.4 minutes. 1 minute 4 seconds. 1 terabyte. Sorting is a complex operation. Such kind of complex operation on 1 terabyte, that is done by the Spark in 1.4. Understood? So that is what the power of Spark. So most of the cases you will not be using Databricks, but in some special cases you have to use Databricks whenever you are feeling some processor are going slow. Got it? But nowadays organizations are recruiting separate ADF developers, separate Databricks developers. In the Databricks, the backend framework is Spark. The Spark coding will be done by Scala, Python, Spark with Python, that is called PySpark. Still other languages like R language, even Java, in this domain. Got it. So initially you can step as the ADF developer, later you have to migrate to Azure Databricks also. Okay, because future industry needs combined skills, multi skills. Okay, so initially our concentration, you will be understanding each and every product, but major concentration will be laid on ADF part. And still other data engineering products we have, that is Azure Streaming. The next product is Azure Streaming. The purpose of this Azure Streaming is to capture faster streams. Faster streams of data. And to perform micro batch. Micro batch processes. So what is the meaning of streaming data? What is the meaning of streaming data? Live data. Everything is live, man. I'm doing a transaction, that is also live data. So streaming means without user interaction, lot of data is always keep producing. Example, put a sensor here, sir. Install a sensor. What sensor is doing? Even whether you interact with that or not, it doesn't matter. It captures data. Got it. IoT is one of the best examples. Got it. And also your database logs. Even though whether you insert a record or read a record, it doesn't matter. Some internal processes are keep running so that logs will be keep generated. Logs are example of streaming data. Maybe OS logs or database logs or web application logs. The web application logs simply called as web logs. But the problem with this one is, if in a second 1 terabyte worth of log generated, that means within seconds millions of log records are generated. With how much speed the logs are generated, with that much speed the capturing should be done. And then perform micro batch analytics. Micro batch analytics means for every 10 seconds how many users are coming into my organization. Example, previously for every day how many people are coming into my organization. That is batch. But now requirement, situation demands, for every 10 seconds how many users are watching my product. On that area, the online vendors like Amazon, such kind of organizations are interested. Got it. So that is called micro batching. This Azure streaming is used for capturing fossil streams and also to perform micro batches. Okay. What is the period of micro batch we can configure? That might be 10 seconds. It may be 20 seconds. Like, understood. And one more last product here. That is Azure Cosmos DB. Sorry, that went to top. Azure Cosmos DB. Sir, about this Azure Cosmos, in a special session we will be discussing, especially what is the importance of NoSQL, what are the different types, when to use what type of NoSQL. So till then, till tomorrow class, just have an idea. It's just NoSQL database. Okay, that too under what category? What category? You have different NoSQLs like columnar store, key value store, document store, graph store. This comes under document store. You can say document database. Already have different examples. Different products are there in the market, like MongoDB, DynamoDB. Same like that, Cosmos DB is a product of Microsoft in Azure Cloud. Got it? So what is the importance of this product? Why we should use document stores? Even though RDBMS databases existed, what RDBMS databases cannot do, what it can do, we will be discussing in tomorrow class. All of you understood? Yes. So your major work is with ADF. But being a ADF developer, I know only ADF, that is not enough. Okay, being a ADF developer, you have to interact, at least you have to interact with other products. Suppose your client is saying that extract all data from SQL and dump into Cosmos. Extract all data from SQL, perform transformations in Synapse. The results dump into Cosmos. At the time, how to connect with Cosmos DB? How to check that whether data is loaded perfectly or not into Cosmos DB? You need to check and you need to interact with Cosmos DB and you need to check the data. Understand? So that's why don't neglect remaining other products also. So while working with this ADF, you will be interacting with remaining products and everything will be understanding practically. So in tomorrow's session, for 15 to 20 minutes, I will be talking about what is the final product we have discussed, Cosmos DB, which is NoSQL. So then I will come to the tomorrow class agenda. Main agenda for tomorrow class is data engineer responsibilities. Then finally we will understand the difference between traditional ETL developer and the cloud ETL ADF developer. Okay. So difference between traditional and ADF, that means you can say you are designated here, especially in ADF, you are designated as data engineer. Okay. So someone, if you ask them like what you are doing, I'm ETL developer. But like nowadays, the designations are getting changed. The ETL developers are transforming as next level data engineers. Okay, please wait till tomorrow class to understand the difference between traditional ETL and data engineer. Then you can understand data engineer responsibilities. Okay, what are the daily kind of works, daily challenges, everything you will be understand.